Hi, today we're going to discuss static equilibrium, but this time it involves biological systems, mainly the organism or parts of it, like your organs or some tissues. Okay, so for static equilibrium, this one is a prerequisite in order for us to further study biomechanical properties of biological tissues and organs. Um, in here, we're going to apply the two conditions of static equilibrium. So the first being that the net force must be zero, okay? Whether it's along the x-axis or the y-axis in your xy coordinates. The second one is that the summation of forces or moments rather should be zero, okay? Here we will adapt the convention that the clockwise moments will be positive and counterclockwise moments will be negative. Okay, so let's have this problem. It says here you are able to hold your arm in an outstretched position because of the deltoid muscle. Okay, it's shown here in this figure. And the force diagram for this is shown. So we call this the free body diagram. Use the three equilibrium conditions to determine the tension in the deltoid muscle. So you have here a tension, okay, force, when you hold your arm in an outstretched position. So determine the tension needed to achieve this equilibrium and the magnitude and direction of the force exerted by the scapula on the humerus. So assume that the weight of the humerus is 8 pounds and the deltoid muscle makes an angle of alpha, which is 17 degrees to the humerus. So it's shown here in the diagram. So this angle should be alpha. So let me put here my pen. Okay, this one is alpha and the value is 17 degrees. Okay, so when you hold your arm in an outstretched position, there will be a force T or tension T, okay, in this deltoid muscle. And it's shown here in the free body diagram. So it's sort of a reactive force, okay? So you can see the direction of the tension force here, okay? Aside from that, there is a force directed to the humerus, right? So ito yung force na yon, okay? So this is the humerus part. This one is the shoulder blade, okay? So this is the shoulder blade. Ito yung humerus. So there's like a reactive force being applied on this position. So what we want to find is this tension here and the force exerted here. And we would also like to find the direction also of this force right here. Okay. In other words, what should be this angle right here? Okay. So anong angle kaya to? Let's probably call it angle theta. Okay. So here I again showed you the free body diagram, okay, wherein I already incorporated the angle theta here because later on we need to find that one, okay, in order to complete the solution. And also, it's indicated here that the weight of the humerus is mg, and remember from the problem, it's 8 pounds. Okay. And you're also given the distances of these points here to the humerus or the pivot point. Okay, so we need to use the three conditions or the two conditions of equilibrium, beginning with the summation of forces along each axis. So for the x-axis, the summation of forces will be zero. So what are the forces that act horizontally? Okay, so first, yung T natin dito, okay, yung tension. So ganyan yung direction niya, right? So the T here, okay, or the tension T, you can see the direction. Okay, but we want to resolve this force into its components. So it has a y component. We can probably call it ty. Okay, and meron siyang x component. Okay, T sub X. Okay, sorry about my writing here. So, ano pa? Yung force dito, okay, ganoon din. Meron siyang y component. We can call it Fy, probably. Okay, and then meron siyang x component, Fx. So now let's go back to the question. Ano yung forces na makikita sa horizontal direction? So, number one, yung Tx, right? Yung horizontal component ni tension T. So that will be Tx. But what is Tx? So we can actually compute for Tx in terms of T. Okay? If we're going to use this angle alpha here, we can say that Tx is what? T cosine 17. Okay? Because cosine is opposite over adjacent, right? Or sorry, it's adjacent over hypotenuse rather. Okay. Ano pa yung mga force na nasa horizontal direction? Si Fx, right? And Fx naman, okay, if you are going to utilize this angle here, so Fx will now be F times cosine of that angle. Now, bakit negative dito? Bakit positive doon? Because the x component of your T is going to the left and the x component of your F is going to the right. Okay? So doing the same for the forces along the y axis. Okay? So ano yung mga yon? You have this going upward, so we will include that. Positive kasi pataas. And that is equivalent to T sine 17. Kasi may angle alpha ka dito which is 17 and the y component is T sine 17 because sine is opposite over hypotenuse, right? And then si F, mayroon din siyang y component, okay? And the y component, Fy, is equivalent to F sine theta. Negative kasi pababa. Aside from that, meron ka pang force pababa na 8 pounds, which is the weight of the humerus, okay? So as you can see here, you have how many unknowns now? We have F, we have the angle theta, and we have the tension T. So we have 3 unknowns. We need a third equation, and that third equation will come from your summation of moments. Okay, so how do we go about this? So remember that moment or torque is the force times the perpendicular distance. Okay. Now, where would we assume or put the point wherein we take the summation of moment? Okay, so you can choose any point. You can choose this point. Okay, you can choose this point. Actually, any point will do as long as you know the relative distances. Okay, you can even choose this point. But the best practice is that you choose a point that will try to minimize or simplify the problem. Okay? Maybe choose a point kung saan ma-eliminate niya ang isang unknown. Okay? And that point will be this point. Okay? So this point. Why? So, sa moment, if the force passes through this point coming from any direction, okay? For example, si F, it passes through that point. Si Tx, it also will pass through that point, okay? So those forces that pass through that point, okay, ang moment nila, 0. Okay? So that can be eliminated from the equation. So bakit gano'n? Kasi yun yung point of pivot. Okay? So kumbaga, pag nagbubukas ka ng pinto, para mong binubuksan yung pinto dun sa hinge. Okay? In other words, wala kang mapoproduce na rotation or moment. Okay? So any force passing through or that can pass through that point or that can go through that point will be 0. In other words, you can only consider those forces na may distance from that point. Okay? So, automatically si F, hindi na siya kasama. So, you can eliminate that from the equation. Walang problema yan whether you use F itself or Fy or Fx kasi lahat yan 0. Okay? So, si Tx here, it will pass through that point as well. So, it will not produce a moment. So, what forces will produce a moment? Yung Ty, okay? Tsaka yung weight lang ni humerus, 8 pounds. Okay? So, how do we go about that? All you have to do is multiply the force and the perpendicular distance. So, starting with what? Ty. Okay? Tx, wala na yan. So, Ty na lang tayo. Ty is, again, T sine 17. Tama ba? Okay. What is the perpendicular distance away from the pivot point? So, ito siya. So, Ty, that distance from this point is 6. Okay. So, therefore, you have 6 there. Okay. And ang natitira na lang is yung 8. So, 8 is the force itself, 8 pounds, and then the distance away from that point is 13. Now, bakit negative, bakit positive? Si T sine 17, which is Ty, if you're going to that point here, it will produce a counterclockwise rotation, right? So remember that in our convention, clockwise moments are positive, counterclockwise is negative. So this one is counterclockwise, so negative. While here, si 8 pounds, if you go to this point, okay, mag-rotate ka, clockwise yan. Okay? So, in this summation of moments right here equals 0, ang unknown na lang ay isa, T na lang. So if you solve for T, it will give you 59.3 pounds. Okay. So we're done with the first questions. The question number 2 is that we want to find F. Okay? Yung force from the scapula to the humerus. So what we can do is go back to the summation of force along X and along Y. Maybe we can call this equation 1 and equation 2. Okay, so if you use summation of force along X, equation 1, okay, substitute yung T kasi meron na tayong value ng T. Okay? Ang natitira na lang F cosine theta. So F cosine theta will be 56.7 pounds. Doing the same for equation 2, summation of force along Y. Substitute yung na-compute na natin. Okay? And you'll have an unknown being F sin theta. Kaya natin gustong malaman si F cosine theta and F sin theta. It's because these are the X and Y components of your force F, so that you can get the magnitude of the force F by simply taking the square root of the sum of the squares of the X components and the Y component. And it will give you 57.5 pounds. Okay. If you want to know the direction of that force, in other words, what is this angle right here that connects with the x-axis, all you have to do is take the inverse tangent of the value of the y component over the x component. It will give you an angle of 9.35 degrees.